Simple pendulum. A simple pendulum consists of a mass at the end of a lightweight cord. So we do have this mass, and it's attached to a lightweight cord. And actually, the cord itself, we're going to say the mass is negligible. So we're going to say the cord really has no mass. That's impossible, but we're going to assume that. We're also going to assume that the cord doesn't stretch. That's an important characteristic as well. Without going through the derivation, there are two important equations. One is for period. So period equals 2 pi square root L over G. You might want to write that one down. What that stands for? Well, we know period already. And its units are seconds. We've done that already in the beginning of the unit. 2 and pi are constants. Pi is 3.14. And L is the length of the pendulum string. And we measure length in meters. And G is another constant that's equal to 9.8 meters per second squared. That's just one of those numbers that you kind of have to remember. G is the acceleration due to gravity. That's the acceleration that gravity will pull you down to the center of the Earth. And it's 9.8 meters per second squared. And it's meters per second squared because it's an acceleration due to gravity. The other equation is just the inverse of that. It's frequency, and we know what frequency is. Frequency, and its unit is hertz. We've gone through that at the beginning of the unit too. So these are our two big equations that we have to recall. Period is 2 pi times the square root of L over G, and frequency is 1 over 2 pi square root G over L. Our first problem, what is the period? So we're looking to solve for period, and its units we know are seconds, of a pendulum with a length, so its length is going to be 2 meters, near the surface of the Earth. Well, we know if we're talking about Earth, we know the acceleration due to gravity is 9.8 meters per second squared. So notice that I've written all my givens down first. That's the first thing you have to do. Here's our givens. I've written our givens. Next thing that I want to do is select an equation that will work for us. We have period equals 2 pi square root L over G. I've written the equation. Now what I need to do is isolate the unknown variable. Well, I don't really have to do anything because we're looking for a period and it's already all by itself. It's isolated. Then we need to plug in our values. L, they told us, was 2.0, and G, we said, was 9.8. If we do the math, we'll come out with a period equal to 2.81 seconds. Let's see. What's the frequency of the pendulum? Oops. What's the frequency? And remember, that's going to be in hertz. Of the previous slide, length 2 meters. Near the surface of the Earth, well, that's G equals 9.8 meters per second squared. Well, let's go back and look what the period was. It was 2.81 seconds. So period equals 2.81 seconds. So frequency is 1 over 2 pi times the square root of G over L. And we can plug in those values and we get 0.36 hertz. There is a shortcut here. We could say that we know the period is equal to 2.81 seconds. And if we want to know the frequency, well, frequency is just 1 over the period, which is 1 over 2.81, which will get you back to the same number again. All right, so now they tell you something which is kind of interesting. So long as the cord can be considered massless, Really can't, but okay. And the amplitude is small, so we're not going more than 15 degrees. The period, it does not depend on the mass. So period is independent of mass. Period is independent of mass. And if we look at the equation, period equals 2 pi times the square root of L over G. Do we see m, which stands for mass, anywhere in this equation? No, we don't, which means the period does not depend upon the mass. And that's a very interesting concept. And I'll try and post a Walter Lewin video that really displays this very well, and you'll remember it the rest of your life once you watch the video. Which of the following factors affects the period of a pendulum? So here's the period of a pendulum, 2 pi equals square root L over G. So let's look at our choices. Does the acceleration due to gravity affect it? Well, the acceleration due to gravity on Earth is known as G. So yeah, that's a good one. The length of the string. Well, yeah, the length of the string is going to affect the period too. So that's a good one. The mass of the pendulum. No, mass is not part of this equation. So we're looking for a choice that has 1 and 2, and it looks like choice A.